Hi, thanks for checking our channel here. This is going to be a test and repair video on a Gallagher M800, the old style version. The complaint on this one is that it arcs into the outlet, which I'm not sure exactly what that means, but it's either, if it was a GFI or something, it would probably be tripping it. And usually what causes that, to either arc inside the outlet or trip your breaker, and is, on a fence charger. 90% of the time, if it's not a board related problem, it's going to be your transformer on the unit, and that's what's wrong with this one. And I wasn't for sure at first, but we worked on another one of these, I believe, for the customer, and they swapped it out with the one that we'd fixed, and that's working fine. And so this one, so as soon as you plug in, like the first two pulses are good, and like third pulse it arcs inside the breaker. So they said he put another one on there just like it, just same exact model that we worked on just previously, and that one's working fine on the same outlet, same fence, same everything. So this one we got to put another transformer in, and Gallagher themselves no longer make a transformer. So there's two options. Either the customer spends $400 on a replacement unit from Gallagher, which is a new style M800, or we put a new transformer in and retrofit one, and that's what we're going to do. We're going to retrofit a transformer into this. We'll check everything else out too while we're at it, capacitor and all that stuff. But here's our information. There are links in the description area below. Fencer Fixer is our website, fencerfixer.com. They also work on cattle scale, livestock weight scales, and low bars for both True Test and Gallagher. That's the primary brands that we get in for repair. But we're going to get this unit apart here. I got boatload of videos on this particular unit, but this is kind of a unique situation with the thing. Something smells a little funny on the inside. It can smell like an electrical burn smell on it. Not like heavy, but not normal either. I opened it. I don't see nothing burnt in the board. Usually the thing that smells up the most when you have that electrical burn smell, this big MOV right here. They have orange, blue, red, green, black. They've used all sorts of ones like this, but they're all about the same color, same size, about the size of a dime. Maybe a little bigger than a dime. Capacitor is probably original. How old is this thing? This is a 1999. See, 99. That first two digits there. 99. This is 1999 model, so what, 25, 26 years old. So this capacitor is probably original. This is the old beige ones, the plus the Ducon ones, the 40 microfarad used. So I imagine it's probably a bit weak. Let's check it real quick. That strap's not holding anymore, so we got to replace that. That's why the capacitor is kind of sliding around there a little bit, but that's an easy fix. That's nothing. All right, let's put this meter on capacitance. Let's just go across here to here. 38.2, that's pretty darn close. All right. Okay, so let's get the wires unplugged, because the transformer we're going to stick in here, we got to modify some stuff on it. This one, I think this wire here we can leave. I'm just going to pull it back out of the way. We're going to get this transformer out. We have to modify the new transformer. We just have to bolt it to the case. And see, here's how you can really tell that it's probably the transformer, because you can see this wire here. Not all of them had this, but a lot of them did. It's your ground wire going back to your AC power cord and stuff. So it comes up and over and grounds itself to these metal plates that are part of the transformer. And this transformer has the little wire soldered on the back side of the transformer. It goes right down in the same spot. So that's why it's arcing. This has got an internal short, and it's back feeding, arcing to the, it's either a hole burnt in this thing, and it's leaking, and it's arcing out to the case, or to the metal plates. And the metal plates, since it's metal on metal, it's feeding that arc through this and going back that way. That's likely what's going on. Or there's just an internal short in the transformer, and it's back feeding that way. But either way, we got to get this transformer out. And these metal plates can be real bare to get out of here sometime, but these, oh yeah, see, See some crust on there. Yep, that's the smell I'm smelling. I'll show you when I get this thing out of here. Hopefully it comes out easily. Yep, come on. Yep, look at that. That's why it's doing what it's doing. I thought I smelled electrical burn smell. Not like heavy. But yeah, it definitely stinks now. It's not that bad, but it definitely stinks. Smelled worse, but that's not too bad. We'll throw that away. Alright, let's... Alright, where did I put the transformer that I'm going to stick in this thing? I brought it over with me. There it is. Alright, this is the transformer we're going to stick inside. This already has the plates built into it. It's all taped up, ready to go. So we've got 4 wires here. These big wires here are primary for the... goes to the board and capacitor, and these 2 are secondary for the fence and ground. So what we're going to do, I'm going to set it in like this. I'm going to temporarily feed the wires through. There's 2 little holes back here. Feed them through those little holes there. This is a little bit narrower one, so this is it kind of flop around inside there. But what we can do is we can rest it on this little lip here. This little black plastic lip there. The old one set up. We're going to rest it on there. Push all the way in, and we're going to use that to help let the transformer kind of sit stable. And we're going to run a bolt through this hole here. This is going to go through the case, and we'll put a nut on the top side and run that bolt through. We'll put a spacer in between the frame of the transformer, the metal plate in the case, and that'll keep it, something to sandwich on, so it keeps it in place. So I'm gonna got the nut. I gotta find the right bolt. Where is it? I think the skinny bolts I use. Okay, I think these are going to be the ones that are going to work. Okay, yeah, that's going to work just fine. Alright, now I need a little drill bit. Something small enough to get in that little hole there. That's going to work. And then we'll need probably make 2 holes, possibly. Depending on if this bolt just goes right in like we want it to. Oh yeah. Okay, so now we'll get this ready. I'm just going to kind of prop it like that. I need to get a spacer out for the transformer to set on over in that corner. I think we'll use this one here. I think it's going to work. Plastic spacer, and then we'll get this transformer, get the wires fed back in. So the transformer all the way over. Hopefully, she's just going to shove that right up there. All right. Okay, get that nut. Put that on top here. Spin that on there. Yeah, so if you've got a AC unit that keeps tripping your breaker, or it's arcing on your outlet, it's most likely a transformer issue. Now, if it's on a GFI or GFCI, whatever they call them now, and it's arcing like that, or not arcing on the inside like this one probably was, but it was actually tripping the GFI. And this is the first time it's ever done it, but this is the first time we've really ever used it on GFI. Most likely, there's nothing wrong with the fence charger, especially if it's a brand new system. It's not compatible with the GFI. And you're going to have to put a regular outlet, or if by code that outlet, the GFI has to stay there where it's at, you're going to have to plug it into a standard outlet somewhere else. Because some units can have a feedback deal coming in through the AC side. That's just part of how they're built. Some brands are like that. And that can it's just going to keep tricking the GFI that there's a problem, or there's a surge, or whatever it's doing, whatever it's thinking, and then you're going to have to do something different. No, I've only seen it happen on like a small handful of systems. That's why I think in some of the books on these fence boxes, they'll state on there not to use this unit on a GFI. Not all of them say that, but some of them do on some brands and models. Okay, let's get this capacitor in place. I'm not going to replace it. I mean, they're not going to gain that much. Between 38.2 and 40 was that 1.8 microfarad difference. They're not going to see that much gain by putting another 40 microfarad capacitor, especially for what the 40s cost. They're not going to gain all that much. I mean, eventually it's got to be replaced, and this one may have been replaced at some point in time. It might not be the original, but plus the Ducon, these beige ones, they were used for quite a while. I need a piece of double-sided foam. Let me go grab some real quick. All right, it's a piece of 3M double-sided foam tape. Put it right over there. This is going to do two things. It's going to help hold it there, and keep it from moving. And then we'll also put this on there as well. It's kind of like double protection. I think some of the earlier models of these Gallagher had double-sided foam behind theirs as well. Double-sided tape. Alright, so now let's get this part of it ready. We're not going to need... what we could have done is probably put that on there and... We don't necessarily need that. So what we've done in the past with some models is cut that off. You don't actually... And some versions of this only had a 2-wire plug on them anyways, and there was no ground lug over there for off the transformer, so it's not a needed thing. Alright, let's see. Now we're going to crimp on I'm going to have to do some splicing here in a second, some solder and stuff, so I'm going to get my heat gun, or my solder iron warmed up. I'll put this on here. And then we will crimp that back side, or side there. This black wire is going to go right here. Come on. Come on. Alright, see, this is not going to reach right through unless we solder it on there, which I don't want to do that. So we're going to snip it there, and then we'll take this wire and we'll snip it. We'll kind of cut it right there. Strip that back just a smidge. Now I need a piece of heat shrink. Might work. This will definitely work, so we'll use this piece. Alright, we'll slide this down like here. We'll slide over here on this one. Alright, so now we'll get some solder out, and we're going to tin the wires, what we call it in the industry of electronics and soldering and stuff. And tin the wires and add some solder to the iron to tin it. And we'll hold our iron on the top side and go to the back side and add solder there, so that way it flows through the wire and to the iron itself, because solder flows towards the heat. Same thing there. Okay. Now, hold them right on top of each other, side by side, real close where they're touching, and we'll heat them both up together. Moved on me. Ow. I think it's pretty hot to hold. Knock my fingers back far enough it didn't get too hot. I've got a new heat gun, but I don't have it here in front of me, so another way you can, if you don't have a lighter, which I don't have, you can take a soldering iron. Ours is set to about 800 degrees Fahrenheit, and we'll just heat this up. Just keep running it back and forth. It won't melt unless you leave it on there way too long on one spot. But just rub it back and forth, and you'll see it kind of shrink up on you, which is what you want. It takes a little longer than a heat gun does, but I don't mind. Original heat gun I had broke after 10 years. And the other one I've got, I just haven't got out of the box yet. Alright, there's that. Now we'll take this board. It's got the original circuit board, 1999 board in it. So that's new. Now this isn't new. This is 1.1. That's a 2011 output VDR board, they call it. That's been replaced, but that was 13 years ago. Alright, let's get, need a couple of male spade connectors. We're going to cut all this excess off that we don't need. We only need like a 1/4 inch or so sticking out. And then we'll put that on there. We'll get our crimping tool. Make sure it's right where we want it. Where the wires at and everything. Okay, there's that one. Let go. I'll do the same thing over here. Put that there. Okay, now let's take those, put those in a little hole there. Now I'm going to take let's take these little pieces here. We're going to make sure they're nice and straight inside there. We're going to squeeze down on here. And then we'll whoever worked on this, saw this board, did it the hard way. Supposed to widen these up. It's a lot easier to install. But whoever did it didn't do that. That's why they probably wasn't sitting in all the way last time. Alright, let's turn this around. Let's plug it in. See what kind of voltage output we're getting. Lights flashing. That's good. Now we'll put our tester on it. Let's see. We're going to slide this over a little bit. Now we're looking at open circuit voltage right there with no load on it. Getting 9,000 volts out of it there. Alright, put a 500 ohm load on it. So 3 joule output at 8.7, so it went down a little bit. Let's go to 200 ohm load at 4.9, 4.7, 4.6 joule output at about 7,000 volts. So this is an 8 stored joule unit. We're getting about 5 joule output. Okay, we're at 100 ohm load. This ought to really drag it down. Up a little bit, about the same joule. We're at 5.4 kV at about 5 joule. See what the pulse speed is on it. So how fast or slow it's pulsing. So now we're on the pulse speed setting on the meter. So this size shows how often it's pulsing, how much per second is it, or how often is the pulse speed. And this would be how long is that shock duration actually on the line for. So it's pulsing about every 1.1 second, and it's 0.03 millisecond is how often that shock is actually being, on the line itself. So the one on the left is how fast its pulse speed is, and that's how long the actual shock is on the line. So really fast. Alright, so this seems to be working great now. So now we are done with this one. Alright, so I'm gonna, that green light, well, yeah, I lit it. Just want to make sure. Alright, well, 8 stored joule, 5 output joule. So, well, he had a little screw here that he put in the case. Where it went, but I've got my screws by the box full for different stuff. We'll put another one in that we use. Alright, well, kept another one being thrown away because if Gallagher themselves had gotten their hands on this, would have been put right in the trash. So we kept another one from being thrown away so I can go back to work and do some more shocking on the fence. I've been ashamed too, because the rest of this unit's fine. One bad part was all that was wrong with this thing. The other 3 parts are perfectly fine. So why would you throw away a $400 fence charger because the one part was bad? So you throw out 100% of the unit for only 25% of the problem that was wrong with it. So they always talk, Gallagher's always big into sustainability and stuff, but help the planet and stuff like that. Well, kept this one out of landfill for you, Gallagher, so I'm helping you guys out. Yeah, it cost another lost sale for the product, but this one's all right, ready to go right back to working. Let's see what kind of spark it throws. Hot. All right, until next time, we'll see you guys later.